Here they come.
Well, folks, let folks roll in here. Will, we might have a few folks sitting around on this nice icy day. Nothing better to do than to listen to a webinar.
Cozy up.
That's right. We'll let folks roll in here. Yeah, good afternoon, everybody. We'll give everybody a few more seconds to come in. I know it's if you're anywhere close to where Will and I are, the ice is building up on the trees. So what's happening on solar panels on a day like today, Will?
Well, the same thing that's happening to the trees. There'll be a little bit of ice build up.
Yeah.
We don't really have much sunshine happening out there, so there's not going to be a lot happening on the output of the solar panels themselves today either. There'll be a trickle. You know, we'd see a steady sort of trickle with this amount of light, but nothing significant.
Yeah. I know the panels we have in our house, the ice, it slides off the panels before it slides off the trees.
Oh yeah, for sure. Yeah, because the surface of the solar module heats up. Actually, even on a day like today, it'll be a few degrees above ambient temperature. So,
right, very good. All right, folks. Well, we're going to get started. So welcome to our Thursday Critical Canadian Home Building Science Series, part 11, I think. Are we 11? Yeah. Today we've got Will Beardmore with us. We'll do some introductions here in a bit. And Will's going to take a bit of a deep dive on photovoltaics and renewables and energy management in the residential sector. And we'll introduce Will a bit more here in just a minute. But as we get started, real quick, a thank you to Enbridge, who supports these presentations, and as well to Susan Cudahy. So Susan is the supervisor of strategic builder relations for Enbridge Gas. Susan and her team work with builders, developers across Ontario, helping them build simply more efficient, better homes for Canadians. They're through the Savings by Design program and others. So if you have interest in those programs, reach out to Susan and team. But again, we're very grateful to Enbridge for supporting some of these webinars. So in the background, Stacy on the Building Knowledge Canada webinar is going to run a poll, and let's find out where you're joining in from. First of all, tell us where you're from. And if you're not on the chart, put it in the chat. I think our farthest reach was we had Spain at one point and Costa Rica at another, Bolivia at one point in time. So, hey. Jeffrey from New Brunswick. Excellent. Good. Look at that. We don't even have New Brunswick on there. What's with us? I guess we say Atlantic provinces, don't we? Probably shouldn't just lump everybody together. Good to have you, Jeffrey. Excellent. So let's see where you folks are from here. So we've got a number of folks from Ontario, got Alberta, we've got some British Columbia, some Atlantic provinces. Excellent. Good. And one more question before we get going. What keeps you busy day to day? So again, Stacy's going to run that poll. Just tell us what you do, where you fit in. And again, if it's not on here, just throw it in the chat. Oh yeah, that's right. We can only put 10 choices into the Zoom poll. There you go. Good. Now we have somebody from Reinsurance, Randy. Good to have you today. And of course, a number of others as well. All right. Let's see what comes out as. So we've got a number of developers, renovators, number of engineers, architects, site supervisor staff, energy advisors, building officials, inspectors, mechanical contractors, and other. So, Will, you got quite a cross section today to speak to.
Excellent.
So, housekeeping rules, questions. If you have technical questions for Will for the presentation today, please put them in the Q&A and put them in as soon as they come to your mind. Just drop them in Q&A. Don't drop them in chat. And we'll stop once in a while to answer the questions. And then, of course, we're going to leave some time at the end of the day to answer the Q&A. The chat, maybe we can reserve that for if you're having technical difficulties with Zoom. Stacy and the team can help you out there. Or if you have questions on the admin side. There is a Survey Monkey that has been, that will be sent out after the presentation. Please fill it out. Just so you know, your feedback on the surveys this year have already formed the basis for what we will launch in the new year for this critical series. So it's been very helpful to have that feedback from all of you. The presentation links as well to the live webinar will be shared afterwards as well. So you can take Will home with you. I mean, there you go. And the last one, of course, is there is a new feature, closed captioning, that can be enabled that you can have. And so welcome to that. So Will, founder, president of Bluewater Energy. Will has been, I'm going to say, probably one of the preeminent PV renewable energy management, not just a consultant, but actually his company does the practical design and installation for large scale renewables. But Will's been helping CHBA, the LEAP team as well at Enercan CanMet, help to bring the technology into the residential sector. And I will have to say, I don't know anybody that really understands better the practical nature or integration challenges with residential buildings in Canada as Will does. So Will, it's good to have you.
Thank you, Andy. Good to be here.
Yeah, and hopefully you'll be okay, comfortable again sharing with us, you know, some of the projects you've worked on. I know a number of the clients we have on the line today you've worked with, as well as other companies, not only in Ontario but in other places. Myself, I'm Andy. That's what we do, Vice President, Director of Building Science here at Building Knowledge Canada, and members of a number of standing committees and so on. So just real quick, anything I say or we have in these webinars do not reflect, you know, Codes Canada or the work there, but we do feel grateful to be able to participate in a number of areas and those associations. So the agenda today, really, Will's going to walk us through it, is I think, Will, you're going to give us a practical, sort of some contextual breakdown of what goes into the design of solar communities, what you need to know, and then you're going to lead us towards, all right, here's the challenges. Does that sound right?
Sounds about exactly right.
All right, good. All right, Will, I'm going to stop sharing my screen and it's all yours, sir.
Okay, well, I will start sharing then and kick off. Hope everybody is comfortable and cozy and in a warm, dry place on this beautiful spring day.
Yeah.
Okay, so as Andy mentioned here, I'll start off by saying I'm Will Beardmore, president and founder of Bluewater Energy. We've been doing renewables since 2009. We have at this point constructed, commissioned, and have had experience with over 1,000 projects, residential and commercial. We did a lot of commercial originally, transitioned into residential. It's where we're happiest. It's where we want to be. And, you know, the individuals on this call in the industry are among some of the best Canadians I've ever met. And I'm very grateful every day for having the opportunity to interact and partner on projects with, you know, people in this industry. So I'm going to cover some information here. Barriers to adoption of scaled renewable storage and increased electrical loads in homes, Canadian standards and codes, and some key considerations. Now, they might not all appear in this order. I've sort of structured this so that we're going to walk through the process. I'm going to focus on a single detached home, one project initially, and then we'll talk about how we scale up into larger projects such as communities and higher density stuff such as multi-unit residential. So typical stages of a project. we start right at the beginning. So, we look at the plans, the site plan, the architectural drawings, and the energy modeling. Energy modeling is an important component because we need to know what our target is, and that model is what gives us our target in terms of how much generation we want to achieve from the site. So we do system designs. It's an iterative process. It starts with taking, for a single detached home, it starts with taking the architectural design. Oftentimes there are multiple elevations for a model. So, we're looking at all elevations. We're looking at the site plan to determine lot orientations. We're aligning the drawings in the direction that the lots are going to face. And then we're essentially constructing scaled 3D models of those homes. And we're laying PV on the rooftops in the most appropriate directions to optimize generation and harvest. And then we're doing the generation modeling. And so I say it's iterative because we've done this for a number of builders who wanted their communities to be assessed prior to going to sale. And so, it's important to know that the homes that you're offering, if you're selling a net zero ready product or a net zero product, that it can actually achieve that. So in going through the process, we have on occasion identified some models that were not able to achieve net zero or net zero ready because of insufficient square footage available on the roof or just the geometries of the roof itself. And so, done early enough in the process, we can actually advise on how to make changes to the roof lines in order to accommodate more PV in order to get closer to the target or all the way to net zero.
Is it fair to say, Will, that very rarely have you actually been able to have influence on the site plan design? Most of the time it is what it is, right? Like you've got no option.
Yeah, and that's a great point, Andy. It's like, the site plan is a site plan, and quite frankly, I mean, you're probably not gonna change that, or you're not even going to be thinking about sort of orientation when you're laying that out, because all the factors that go into a site plan ending up the way it is need to continue to be the reasons why it ends up the way it is, and then we work within that sort of that framework from that point on. So gotcha. And quite frankly, with the efficiencies of PV and with the performance of the homes improving and the loads coming down, sort of it's a rare home that we can't actually get to net zero these days. It does happen, but it's rare. So then additional steps in the process here: local distribution company, that's the utility application, engineering review and approval, building permit submission, electrical permit, plans review if required. In Ontario, plans review is required if we're over 10 kilowatts of generation capacity. It's sort of different by region, and sort of other provinces have different thresholds there. I think British Columbia is 12 kilowatts. The PV energy storage rough-in, the PV energy storage installation and connection, electrical inspection, energizing and commissioning, setup of monitoring, and then handover. Okay, so the design process. So we are taking the architectural drawings and we're basically remodeling that drawing, and we then create a scaled 3D sort of design that represents the home. And then with that scaled 3D design, once we orient it in the direction that the home is going to face, and if we, if this is a project that is, or a design that's being done before sale, and before we know which model is going on which lot and which direction it's going to face, then we do it for each possible lot orientation in the community. And so we identify the roof that faces the most optimal direction. We lay out PV. The PV layout is scaled as well. So, we're at this point determining how much PV, i.e. how many solar panels we can put on the roof. And then based on the pitch of the roof, based on the orientation, we're getting a generation model, which we can then compare against the energy model, verify that we're hitting net zero. And you can see in this case, we're actually at 107%. And sometimes we do that because the energy model doesn't factor in things like electric vehicle charging. So if we want a little bit extra generation to cover that off, we can factor that in. So the utility process, this is a pretty critical step here, because it's essentially a go, no go. Well, it's not a go, no go. There are things we can do if we do not get permission from the utility to connect. But primarily, this is the way we want to do it because it's the least expensive. And if you think about it this way, the utility actually serves as the battery. So any excess generation that happens during the daytime that's not being used in the home is actually going out to the grid. The meter is recording any generation that goes out to the grid, and the homeowner is getting credit for that. That credit carries forward for up to 12 months. After 12 months, the credits reset, and that's a conversation that we're going to have in a little bit here. So the impetus and the incentive really is only build a solar array that is large enough to meet the expected demand, because if we build an array that's larger and generates more, then the homeowner is actually adversely impacted by that financially. So
that's interesting. I've often heard you, Will, and very wisely say to a lot of homeowners that want to, say, put on enough solar to do all their expected loads, EVs and everything else. I've often heard you explain to them, well, let's start out with a little, see what you're using, and then maybe add more later. Is that sort of along that line of thinking too?
Yeah, it is definitely more advantageous to the homeowner to start with a moderately conservatively sized. I mean, your energy models, Andy, that we use for net zero analysis, let's say, those are very good. And when we compare expected performance versus actual performance, we're pretty close. But if somebody says, hey, I want 20% or 25 or 30% more, then we sort of caution them, because the way the utility does this, and this is an Ontario regulation, so this isn't something that any one utility has the ability to change on their own. And the Ontario regulation says that if a homeowner is in a positive credit situation for 12 consecutive months, i.e. they have net positive export every month for 12 months continuous, then any credits that are on the hydro bill at that point or on the account are zeroed out. The homeowner gets no compensation for that, and then the account starts over. So we've actually seen a couple of scenarios where the homeowner didn't use as much electricity as was generated, had something like $1,100 in credit on their bill, and after 12 months, the utilities zeroed that out. They received no compensation and no benefit, and then start over. So we're pretty careful about that. We do advise every homeowner at the start of every project, even if it's a builder client, which most of our projects are for these days. We do want to have that conversation with the builder's client, the home buyer, just to make sure they understand, and so this gets into that conversation about we're offsetting gas energy as well as
that's right. Yeah, that's right.
If we're compensating, if we're building systems to offset gas energy as well as electrical energy, then right out of the gate, we're designing a PV system that's actually going to generate more electricity than the home is really designed to consume. So we do have that conversation up front. So if we're under 10 kilowatts, which which is the limit we definitely want to stay at or under for residential projects, then, the application with the utility, it's called the Form C. It's quick, it's easy. There's no cost for the application fee. I say relatively low connection costs. Connection costs vary by region. There are a couple of LDCs that actually don't have a connection fee. And then, we go to the other extreme, which is Toronto, that connection costs are around $2,500. Average connection costs are about $400 to $600 for most utilities. Hydro One is $800. And that covers the cost of the bidirectional meter, the utility sending a crew out to pull the smart meter and install the bidirectional meter, administrative work, whatever have you. Once we go over 10 kilowatts, which we would only do in a community sort of scenario, we wouldn't really do this for a single family home, because the expense, and I'm going to cover this shortly, but the expense jumps significantly. And then this process requires a Form B. It's an engineered solution. It's a stamped single line diagram. There's a cost for the application. It can be as high as $5,000 or $6,000. And then the connection costs we've seen can be anywhere from $6,000 to, depending on the size and the capacity of the PV system, we've seen connection costs that were north of 200,000. So,
Oh,
you know, this is something that is that you know, there needs to be real benefit to the actual PV system in order to justify these costs. And the utility views PV and energy storage systems as parallel generation sources interacting with the grid, which they are. And I'm going to get into that in a little more detail in a minute. So then there's an engineering review requirement. So the building code, national building code, as well as, you know, I know Ontario for sure, specifies that anything that's going on the roof that is greater than 5 square meters, and the specific language is actually solar collectors being installed on a structure greater than 5 square meters require a permit. Now, the definition of solar collectors is sort of debatable. Some building departments have actually changed the language to say solar collectors and or PV modules. So anyway, what you need to know is that a permit's required. So that basically requires an engineer review, and you know, so it's a structural engineer is going to review the roof design and the design loads. They're going to review the loads imposed by the PV system, and then they're going to provide a stamp letter confirming the structure is going to support the added weight of the PV system and sign a commitment to review so that the permit application can proceed. A PV system on a pitched roof is typically going to add about 3 pounds per square foot. So we advise builders to sort of add in 3.5 pounds of capacity on the, you know, on the roof design on a pitched roof. And then on a flat roof, because we're ballasting the system, which means we're weighing it down with concrete blocks. The weight load, the dead load can get up to 9 PSF. Typically speaking, we see the total loads around 6 to 7 pounds per square foot on a flat roof. It all depends on the design, the location, prevailing winds, that sort of thing. So then the building permit. So again, requirement varies by municipality. Markham actually doesn't require a building permit for PV systems being installed, which is great if you're in Markham. It's the only municipality I'm aware of. Everywhere else, we are required to get a building permit for the installation, which requires, again, structural certification, mounting details, PN stamp designs showing the locations of the modules. And then in some jurisdictions, the building departments are actually asking us for a site plan showing and elevation drawings showing the home with the modules on the home, and then distances to lot lines, property lines, and elevation drawings so that they can have a look at the planned height of the PV system once installed versus the permitted height of the structure. So
gotcha.
Yeah, so it can get pretty involved, and sort of on a one-off project, okay, but then once we start, and I highlight these things because once we start talking about doing PV at scale, and we start talking about doing all of this for 300 homes in a community, you can see how the administrative work actually becomes a significant factor in executing the project. The electrical authority having jurisdiction in Ontario, that's the Electrical Safety Authority. Other provinces have their own electrical authority and inspectors. All provinces sort of base their code if they don't have an individual one on the Canadian Electric Code. So, the requirements are pretty standard here. All PV and electrical or energy storage systems require permitting prior to starting work. Projects greater than 10 kilowatt total AC output capacity. So that includes the PV inverter and any AC output from your energy storage systems, such as a Tesla Powerwall. A Tesla Powerwall is a 5 kilowatt generator in terms of output capacity, and that's where the utility and the electrical authority sort of view it. It's a 5 kilowatt generator. So a 10 kilowatt PV system with one Powerwall, we're at 15 kilowatts of total generation now, and we require plans review. So that's how that works. Projects that are under 10 kilowatts AC do not require electrical engineering, as pretty much anything that we're doing is prescribed by code, and as long as the installation meets code, then we're fine. We do run into a situation where electrical inspectors that don't have experience with PV systems and energy storage systems actually slow our progress down sometimes. We've had projects sit for a couple of months because the inspector didn't understand what we were doing. Well, we had to go to technical advisors and we had to sort of move it up the chain of command so that we could get certification and closure on the project. So that does happen. We're trying to educate everybody as quickly as we can, but we do run into it from time to time. Electrical engineering is required for projects that are greater than 10 kilowatts. If we're applying for a connection impact assessment, and I'm going to get into that in a minute. And so here's what a design for plans review is going to look like. We're going to show the PV modules. We're going to have all the technical information in terms of electrical output from each module, right up to the string level into the inverter. We're going to show where the connections are happening. We're going to show overcurrent protection devices. We're going to show how we're connecting, what the point of connection is, and we're going to show conductor sizing. So these are all the things that are required on the ESA plans review submission. All right, so considerations. It's important that that the project is sort of considered prior to construction, and you know, we've come a long way over the past couple of years. A few years ago, PV was a complete afterthought, and often we were being called in to, you know, to work on projects that the home was already built, drywalled, you know, finished, and then we were being asked to install solar, and so that is the not ideal way of doing it. The ideal way of doing it is we're in the construction schedule before a shovel goes in the ground, like any other trade. And then the ideal timing is the rough-in happens when the rough-in for all the other services happen. So your HVAC, plumbing, electrical, whenever those rough-ins are happening is when the PV rough-in should happen as well. And then the solar should be going on the roof as soon as the shingles go down, before insulation and drywall for sure. And then that way, you know, we have access to the underside of the roof. We don't have guys crawling around in a finished attic and trampling, you know, brand new insulation and things like that. So, so we do want, you know, and as a builder, what you want to look at in terms of scheduling is as soon as the shingles are on, you want the PV system being installed on the roof, and then the rest of the stuff can happen, you know, down the road. But that's so we want to take into account the location of the utility meter and the location of the main electrical panel. So, you know, we do, we want to get this, right. So sometimes we have meter right on the other side of the wall, either in the garage or in the basement is the electrical panel. Sometimes we have meter on one side of the home, and then we have electrical panel on the other side of the home, and conduit goes under the garage, you know, slab or something like that. So that needs to happen before, at rough-in, before the garage floor is poured. So that's why I say you want to consider where the utility meter is and where the electrical panel is. Where is we want to consider where the PV inverter is going, where the batteries are going, if any. And I'm going to talk about some limitations with regards to that shortly. Location of the transfer isolation switch, if we're employing such a device, and we do have to do so when batteries are being installed. The route from the rooftop to the PV inverter, the route from the inverter to the point of connection via the outdoor utility disconnect switch. So we need to have one of these for every project, and it has to be located within 1 meter of the utility meter. So essentially we come out from the inverter and then we go back inside, and it's simply a disconnect that shuts the system down from the outside utility or whoever wants to do so. Planned prior to construction so that the appropriate underground conduits can be put in place if required. Okay, electrical code with regards to connecting photovoltaics. So, you know, essentially the PV system becomes a generator, as I mentioned earlier, and a 10 kilowatt array, 10 kilowatt inverter is essentially 42 amps of current at 240 volts. And so there is a limitation in code with regards to how much generation we can backfeed onto a load center. So here's a panel, everybody's seen them. This goes, you know, one of these goes in every home, circuit breakers go on the panel, these feed the loads in the home. So this is a load center. And so what we have been doing typically is we've been actually connecting the solar right down here on a double pole 50 amp breaker and or 60 amp breaker, depending on the size of the PV array. and then backfeeding through the panel, and then any excess goes through these, the service conductors and then out to the meter. So that's how we've been doing it. Well, here's what code says. So code says that the maximum amount of generation we can backfeed onto a panel is 125% of the bus bar rating of the panel. So if we have a panel that's rated at 200 amps, and then we have to factor in what the grid can supply that panel already. So if we have a 200 amp main breaker and a 200 amp panel, then the grid can actually supply 200 amps because that main breaker will allow 200 amps to hit that bus bar. If we take 125% of 200 amps, we're allowed to feed 250 amps onto that panel of generation. The grid can supply 200 amps of that because of the main breaker. So that leaves us 50 amps of room to sort of feed onto that load center. Now, a 10 kilowatt solar inverter is going to output 42 amps, which if you look at that, you say, great, we're under 50 amps, no problem, let's go. Well, the issue here is that breakers can only be loaded to 80% of what they're rated for. So if we're going to connect 42 amps on the next size up breaker, which is 50 amps, a 50 amp breaker at 80% can actually only be connected to a maximum 40 amp load. So our 42 amp output from the inverter is actually greater than that. So we actually have to go to the next size up, which is 60 amp breaker. Because the 60 amp breaker is greater than the 50 amp maximum remaining amount of capacity that we can backfeed on that panel, we can now no longer connect that solar array to the panel the way we used to. So a couple things have to happen here. There are some manufacturers that make electrical panels with a 225 amp bus. That gives us 81.5 amps. And so we have no issue connecting our 10 kilowatt solar array. Or we have to do what's called a line side tap. So we're actually using insulation piercing connectors, and we're crimping onto these here or at meter base. That requires isolation from the utility in order to do so. So we have to bring in the utility, they have to disconnect the home at the transformer on the road, and then we can install the solar. So it's a little bit more extra work now if that's what we're doing. So if you don't have a 225 amp rated panel, that's the only way to sort of proceed on a 10 kilowatt installation. Electrical code with respect to batteries. So we're limited to 40 kilowatt hours total storage capacity in the home now. So code changed May 5th this year, and it says that we're no longer able to put batteries in residential dwelling units. So that's residential dwelling as a home. And that includes all areas of the home, even unoccupied areas such as furnace room, whatever. We are able to put batteries in an attached garage. So the limit, though, is 40 kilowatt hours total storage capacity in an attached garage. We can go up to 80 kilowatt hours in a detached garage or a detached separate sort of structure that is not a dwelling unit. The maximum storage per single storage unit is 20 kilowatt hours. And then the minimum spacing between energy storage units is 1 meter. So what does this look like? 1 Tesla Powerwall is 13.5 kilowatt hours of storage. 3 Tesla Powerwall equal 40.5 kilowatt hours of storage. So 40.5 is greater than 40. However, the code does have an allowance plus or minus 5%. And so the ESA in Ontario, for instance, is actually allowing us to put up to 3 Powerwall in an attached garage. Because of this maximum storage per single storage unit of 20 kilowatt hours, when we stack 2 Powerwall together, and up here, this is a picture of 3 Powerwall stacked together, and this is to save space, and it's an approved certified stacking kit by Tesla that has been tested and fire rated. When we do this, ESA says, we've now taken 2 13.5 kilowatt hour units and we've made them 1, and now we're at 27 kilowatt hours, which is greater than 20, which means that we can't do this. So we've been in discussions with ESA and CSA, which is actually where this rule came from, and we just recently had a ruling that in Ontario we're going to be allowed to do this with a deviation request. So that means that it's an extra step and more time in the project. We submit a deviation request to the electrical authority, and we request permission ahead of time to be able to stack the units. Otherwise, what is required is we have a minimum of 1 meter between, and I'm using Powerwall as an example here. This applies to all energy storage systems. We need a minimum of 1 meter between batteries, battery cabinets, battery modules, whatever have you. So, whereas in the past we were able to sort of do this, now these things need to be 3 feet apart at a minimum. So limitations on, sorry, go ahead, Andy.
No, it's interesting because I remember you talking about this of, this whole dance of having to do, if you wanted to go over, 1 or 2 Tesla Powerwalls, all of a sudden it was, where do you go with them?
Yeah, and space becomes a significant factor in planning the project and even whether or not the project is possible. And here's a little bit of what I consider to be frustratingness. We could take a Tesla Model D. In fact, we could take 2 or 3 Tesla S's that have 100 kilowatt hour battery bank, and we could park that in the garage all day long without a permit or restriction. So we can't put more than 40 kilowatt hours of total storage in a garage, in an attached garage. But we can actually park 1, 2, 3 Model S's with 100 kilowatt hour battery bank each in a garage. So, it's unfortunately we're in a situation here where technology is sort of is rapidly evolving, and those that are sort of looking at this and considering sort of code and how we want to manage it are, I don't think necessarily understand the technology as well as they could or should. And so we have rulings coming down that are very limiting for those that want to actually, sort of push this forward. And some of them just don't make sense. So the output of capacity of a Powerwall is 5 kilowatts. Maximum allowable backup power from 3 Powerwall is 15 kilowatts. So now we're talking about limiting a home to a maximum of a 15 kilowatt backup generator, which is not enough to back up a modern net zero home because of the electrical loads that are going into it. So I'll cover that in a moment. Okay, so the summary, this is again, sort of the list that I went over in the beginning. I'm going to sort of focus on this section right here, the application process to the LDC, structural engineering review and approval, building permit submission, electrical permit and plans review if required. So for a project that's under 10 kilowatts, these things right here, these soft costs constitute a significant percentage of the overall project price. And we're talking on a less than 10 kilowatt project, $2,000 to $5,000. And that's before any equipment is procured or anyone shows up on site to do anything. Greater than 10 kilowatts, we're going to be $10,000 just in engineering and application fees just to apply. And then we're lucky if connection costs are as low as $5,000 or $6,000. And as I said, I've seen connection costs north of $250,000. And so when we're looking at community level stuff, we're over 10 kilowatts. This is the reality of what we're facing. And you can see having to complete each of these steps on each home in a community is going to get burdensome, and it's going to require some significant administrative coordination to sort of make sure it all gets done in a timely manner, complete and accurate. So that's just some of the challenges there that we're going to be looking at. So
how are you finding turnaround time for permitting on PV?
Yeah, the turnaround time is actually, I have no complaints there. I think most building departments are pretty familiar and comfortable enough with it now. They know what they're looking for. The package comes in, it's got the engineer review, it has the drawings and the details for what's happening and how it's attaching, and it's all the equipment sort of specifications. So as long as it's complete and accurate, we're seeing turnaround in less than 10 days.
I see. Okay.
Yes, or LDC, so the application to the utility depends on which utility. We're anywhere from a couple of days to some utilities have actually gotten quite far behind and can be a few weeks in getting a response. So all of these things sort of, and we kind of do these things almost sequentially. So this is step one, and until we have this approval, there's really no point in moving on and spending extra dollars on the project. So we kind of wait till this is done before we start this, and then we wait till we receive this back before we we start this. Sometimes we're submitting these simultaneously, but this one we generally submit and wait for.
So Will, can you speak, sorry, maybe if you're going to do this eventually in a slide, don't worry about it, just let me know. But this question about, are you finding a frequent occurrence of utilities responding with, we can't allow you to connect because there's grid constraints? Are you finding that number going up? Are you finding it going down? Is it a regional thing?
Yeah, it's very geographically specific. We saw large areas of Ontario, for instance, that were capacity constrained in 2012, 13, 14, and then we saw a whole bunch of those restricted areas open up over the past few years. And then recently we've started to see areas once again that are capacity constrained. So I'd say it's been pretty open for the last 3-4 years. Haven't had any issues. Recently, we've started to see issues. And in fact, in Guelph, of all places, Terraview's new community, NEMA, we cannot get capacity in there to install solar. So their plan was to do net zero ready, net zero, and it's not actually a possibility because of the grid constraints. So it depends on where you are geographically. It depends on, and I'm going to speak about sort of those restrictions in a slide coming up. So. Increasing electrical demand. So as we're sort of moving to electric sources for space heating, hot water, we have ventilation happening 24/7, and if the creature comforts are becoming sort of more of a necessity than a want, like in-floor heating, electric vehicle chargers, operational loads. We're talking about appliances, lighting, communications, like internet, whatever, and then charging of things like phones, laptops, other electronics, and then lifestyle loads. People are sort of working at home and have home offices and operating more electricity consuming sort of things. Entertainment systems, pools, hot tubs. With the pandemic, a lot of people started doing fitness at home. And then Andy, it's funny because you mentioned this on the call we were on just before this, crypto mining. It's actually a thing. We've actually done projects for individuals who specifically needed more power because they were mining Bitcoin or whatever have you.
Isn't that something? Yeah, and that Bitcoin, the one you were talking about, this one project in particular, it's extreme draws and it actually very high heat generation.
Yeah.
So they're putting these in the same room as the Air Source hot water heat pump. That's interesting, eh?
Yeah. So all of these things are adding up, and in fact, depending on the size of the home and the requirements, we're now seeing, and we're speaking to builders who are now seeing services sort of hitting the maximum threshold of the 200 amp service, and in some cases the load calcs are saying they have to go to 400 amps, and that jump we've seen costing from utilities upwards of $30,000 to $35,000 to go from 200 amp to 400 amp. So we are looking at solutions to sort of deal with that, to help builders. The one thing we can't do is we can't factor in solar or battery, and I'm going to talk about what renewables can do here now, but we can't factor in solar generation or battery storage and what batteries can supply back to the home to sort of deduct against that, because what the code says and what the utilities sort of want to know is what's the total power draw in the home, even though you've got PV, perhaps even though you have batteries, perhaps. What's the total load in the home based on how much electricity is going to be consumed, because that's the thing that matters.
Okay.
So
I just want to capture that point, because I think Jeffrey just made a point, and this is the thing that triggered, I think, some conversation the other day. We have standard homes, single detached homes, that simply want to do net zero ready, getting ready for net zero or full net zero. By the time you make the decision to, let's say, maybe go all electric, so now you're adding the hot water, now you're adding, and then let's say there's a Tesla, let's say there's an electric vehicle. What you're saying is it's more than likely you're moving past a 200 amp panel, 225, you're likely going to have to look at a 400. Do I have that right?
Yeah, in some cases that's actually what's happening, Andy. And so that's not just a moving from a 200 amp to a 400 amp panel. That's moving from a 200 to a 400 amp service, which means the meter base is now 400 amp rated, which means that the conductors coming in from the road, from the transformer, are 400 amp rated. And so, all of that infrastructure needs to be upgraded in order to facilitate that. And so that's where the extra cost comes in, and that's what we're trying to avoid. Unfortunately, as I mentioned, PV and batteries don't deduct from that, although we can supplement or even offset completely grid supplied electricity consumption with renewables. It doesn't change the fact that the loads are the loads.
Right.
But there is something else. There's something else that we can do in order to manage that, and we're actually trying to achieve this with a project with Chatsworth right now, where they've the homeowner has been told he needs to go to 400 amps, and we're in discussions with the ESA now, and I'm going to speak about that in a minute.
Okay.
So what can renewables do? Solar on-site generation to offset or eliminate annual electricity costs, provide clean, stable power to the grid, reduce the need for other carbon-based forms of generation. So excess generation from PV systems going out to the grid is used elsewhere, and with sufficient enough generation going out, it does reduce the reliance on other carbon-based forms of generation. Charge energy storage systems, so home batteries, charge electric vehicles if you're at home during the daytime. And then obviously we're limited to daytime hours, and we're subject to availability of sunlight. Like today, not a great day for generating electricity with solar modules. And then batteries. So energy storage systems store excess PV generated energy during the day, supply energy during peak periods to reduce utility costs. So if you're on time, if your jurisdiction's time of use and your morning and evenings are peak demand periods with higher rates, stored energy can offset that. Stored energy can also reduce the demand on the grid. And we're small scale right now, but we're right at the start of this thing. As we go forward in time and we see more and more energy storage systems going into homes, the aggregated capacity that can be achieved even in a community can look like megawatt hours. And that energy being deployed at peak periods by the utility is actually something that can be used to reduce or even eliminate the need for natural gas fired peaker plants, for instance. We've got a ways to go, but there are utilities in the US that are doing this very thing now. And there are utilities in Canada that are looking at pilots and or running pilots already in this regard. So there's a lot of potential here.
It is interesting. This last year, we were in Hawaii, right? And so Hawaii has a very electricity was 45 cents a kilowatt. And they have coal generation, trying to get off the coal, trying to bring in the gas. They've got lots of solar, but there's ads on the television, there's ads on social media, there's ads on the street. The utility is begging people to let them put a power wall in their home for free, right? Precisely. And they'll explain it to the folks. It's not because we don't have enough power. That's not the issue. It's we don't have the power when we need it. It's managing the peaks. So
right. Yeah, and distributed energy storage, when we're talking about thousands of homes, it becomes a meaningful amount of energy very quickly. So we're seeing the trends there, and hopefully we're going to get there. I will mention, because it comes up more and more in conversation, and even some manufacturers advertise it, like I think Ford, using the stored energy in the electric vehicle to feed back into the home. This is something that can be done. It is something that I think would make the electrical authorities' heads explode at this point in time. I think we're a little ways off from it being something that's done as a standard, and there's a number of equipment and code issues I think that need to get resolved before it becomes an actual thing. But it's definitely on the horizon. The capability exists, the technology exists. It's just a matter of electrical authorities sort of getting their heads around it, and the equipment ratings being such that it is legal to do so in Canada.
I know there's a lot of, I sit on a couple of CSA committees, and One of them is a committee called the TC 424. So it looks at residential standards. And one of the big points of conversation across many of the CSA groups, and even, south of the border, even ASHRAE committees and standards, is this term, and you just sort of used it, as grid interoperability.
Right.
It's the ability to interact, for all things to interact, but also for the grid to interact with everything else. And it's hard for me to get my head around the fact that the grid can't see anything on the other side of the meter. It doesn't know. It just doesn't know, right? Yeah. So
yeah, and anything that is a point of entry into the home is, i.e., if we're using the stored energy in an electric vehicle bidirectionally, then the first piece of equipment that it interacts with has to be what's called service entrance rated. And so now we're talking about either electric vehicle supply equipment, such as EV chargers, or equipment installed ahead of that, such as disconnects being service entrance rated, and then how we're safely going to sort of operate and manage that system when the car is charging and backfeeding the home. And then, because it's grid interconnected, ultimately those electrons can absolutely push out past the meter back towards the transformer and the distribution system. So it's, because we're all connected, and because electrons are going to follow the path of least resistance, and they're going to go where the demand is, there's a lot of considerations that need to happen. So this is what I had referred to earlier, and we'll call it load management, load control. And so we are working right now to try and get approval for a home builder who's in a situation where they've been told that the home has to go to 400 amps because of the loads. And so if this right here, this picture, essentially what we're showing here is this is a relay that controls power at the individual circuit level. And so the idea here is that we essentially come out of the overcurrent protection, which is the breaker, we come into the relay, and then we go out of the relay to the load. And so now so this relay is paired with a control management device, and it can be interacted with on any web-enabled smart device. And they have a very nice app actually for iPhone or Android. And so once we do this, and if we do this on every circuit, we then have complete access and control at the circuit level, as well as monitoring of any electricity that's being consumed on that circuit. So you can see down here, we have our inputs. So we've got a grid, we've got energy storage, possibly generators. This could include solar. These sources are being fed onto the panel. All the loads are being fed out of the panel. Traditional panel is just circuit breaker load. Now we're looking at circuit breaker, smart relay, or power module, and then load. And then we're able to control, essentially any circuit in the home right down to individual level. And then the nice thing about this system is it's programmable. So we can set scenes that automatically do things. So if you're at home, obviously everything's open and operates. If you're away, non-essential things can be automatically shut off. When there's a grid outage, we can automatically shed certain loads if we have a limited amount of backup power, such as, we're right now, as I discussed earlier, limited to a maximum of 3 Powerwall, which gives us a maximum of 15 kilowatts of backup power. Right. And so, we see loads in homes getting over 15 kilowatts if everything in the home were to come on. So this system can be programmed so that larger non-essential loads are essentially shed, and then they don't receive power in a grid outage situation. The way we're particularly looking at employing this system is, for the home I referenced earlier that we've been told needs to go to 400 amps, is to say, okay, here's all the loads in the home, everything's on a power module, everything's being monitored, and we set the maximum allowable energy consumption at 180 amps, let's say. And then we prioritize each of the circuits, priority 1, 2, 3. And then we say to the system, if we get to that 180 amp limit, or we start approaching it, then, we start to limit what is allowed to operate in the home and what is not. And it will cause certain things in the home to not energize if we're at that limit, and to wait until something else shuts off. So, there could be a quality or lifestyle sort of sacrifice here, but we do have, in this case, a homeowner that believes, they're not going to be operating everything in the homes all at once. So they're never going to be using 300 amps of electricity, let's say, and is quite fine to say, I'm totally okay that if my electric vehicle's charging and I'm cooking a turkey, that I can't run the dryer until, my whatever.
Right. That's right. Yeah. Or the pool pump doesn't run or something.
The pool pump doesn't run, precisely. So we're looking to get authority from, in our case, it's the Electrical Safety Authority. We're looking to get authorization and approval from the ESA right now so that we can employ this. And it will be the first one, and then we'll go from there. So hopefully I'll have some things to report on that in the near future.
Very cool.
All right, so the builder process. So once we move from individual home to community level, same steps happen, just more of them. And so essentially the process is we look at the site plan, as I said earlier. It's going to show us all of the lots, and in this case it's actually quite handy because we know which home is going on which lot, because it's a planned community. In a lot of cases we won't, because that's going to be up to the home buyer when they walk into the sales center to determine which model, which elevation, which lot. But we go through this process of, here's the site plan, here's the lot orientations, here's the architectural drawings. We create a scaled model. We determine how much PV we can fit on the roof. We get a generation forecast from that as well, depending on pitch and orientation. And then, we move to construction and connection. So that's how that works, and how it sort of ties everything together. The process, you do want to engage early. You want to have the analysis done early so that if any changes need to be made, can be made. We have seen architectural drawings amended in order to accommodate more PV than was initially permissible based on available square footage of roof or roof design. And then we do want a review of each elevation. We want a review of each orientation, each model, and each elevation on each orientation. And we want to assess that for total capacity of PV that can be installed, as well as the generation modeling. And then we compare that generation modeling to the energy modeling that building knowledge does. And then we know ahead of time whether we have a home that can get to net zero or not.
Cool.
Okay, so utility interconnection and limitations. And this is, I said I was going to get to this, and here we are. So there are limitations on the distribution system, and this is how we end up having certain areas that are capacity constrained and that the utility won't allow more generation to connect. So, traditionally we've had these massive sort of generation sources centrally located. We feed into a substation that increases voltage so that we can send that supply across the province or across the country. And then we need to step that voltage down so that it is at a level that's usable in our businesses, institutions, and residential sort of spaces. So that's the traditional model. Now, as we insert more generation along the distribution line, this model here, electricity was meant to flow one way. And so as we insert distributed generation sources along this line, and then we're feeding back into the distribution system, and those electrons can possibly flow back the other way. Now we're imposing sort of an effect on the grid that it wasn't necessarily designed to deal with. So there are three sort of limitations. One is called short circuit capacity, one is called thermal capacity, and then the other one is just a total generation capacity permissible on a feeder. And so short circuit capacity is the maximum acceptable generation limit that can be connected to a feeder, and it's limited to either 200 or 400 amps based on the voltage of the feeder. Thermal capacity, this is the impact of generation hitting the transformer station or a substation somewhere along the distribution system, and shall not exceed 60% maximum of the total volt amp rating at the transformer. And then total generation capacity, interestingly, so for micro generation, which is what we're talking about, 10 kilowatts or less, typically for residential projects, because of the costs of going above that, which I'll show you here in a minute. They've set this 7% rule, and it's 7% of the total annual peak at the feeder transformer station that services the property. That 7% was based on rotating machines that generate electricity, such as hydroelectric or any other form like that drives a turbine, like coal-fired plants or natural gas plants or nuclear plants. PV systems are not rotating machines. They are essentially digital and solid state. And so they can react instantaneously. Rotating machines cannot, because let's say when we want to stop the rotating machine from generating electricity, there's a period of time where that generator takes to sort of wind down and come to a stop. Right. PV systems can stop instantaneously. So if there is a fault current detected along the system, inverters are very smart, very sophisticated. They shut down instantaneously. Rotating machines can't do that. So this 7% rule is actually not practical to be applicable to PV systems. And I think it needs to be revisited, because it's a limitation that this is the first constraint that typically hits us, is once we hit 7% decline load, we don't get capacity. So that needs to be raised, or we need to change that for PV systems. And we have seen areas that have been grid constrained for micro generation, where we've put in applications for a larger capacity project and gotten awarded capacity to connect for that. And it's just because of the connection impact assessment. So classification of generators: micro is less than or equal to 10, small is less than or equal to 500 kilowatts on a 15 kilovolt feeder, or less than or equal to 1 megawatt on a greater than 15 kilowatt feeder. And then we get into these other utility scale stuff. But this is where the things that would impact us at a community level, and that need to be confirmed and verified with utility prior to starting. Because as I said, with Terraview here in Guelph, we've already hit a dead end with their new community, and we're trying to sort of work around that at this point.
Yeah, interesting.
Codes and standards. So technology is evolving, code is evolving. We're talking about electrical safety, fire safety. PV equipment has matured quite significantly. We're 15 years into this thing in Canada and Ontario right now. And PV equipment satisfies arc fault requirements, rapid shutdown, anti-islanding. So, we're pretty much over the hump there with regards to PV systems. The one sticking point, as I mentioned earlier, is how do we connect? Where are we connecting that power and feeding back into the home and the grid? And I talked about the constraints that we're now experiencing on doing so through the electrical panel. Energy storage is becoming more difficult. I think this is a result of perhaps code writers, inspectors for sure, not understanding the technology, not being comfortable with it, and then just sort of putting roadblocks up or imposing restrictions without really understanding what the impact is. So maximum storage capacity allowable limits what's possible. So if we only have 40 kilowatt hours of total storage capacity to back up a home, that's a day maybe, if we're lucky. And if we're limited to 15 kilowatts total, in some cases, we're not backing up the whole home because that's not enough power.
Right.
Spacing requirements are becoming prohibitive. So if we need a meter spacing between energy storage units, then we go from needing a couple of feet of wall space to needing 15 to 20 feet of wall space. So it becomes prohibitive in that regard. The net metering regulation needs to be reviewed. The impact of doing full net zero, offsetting electric and gas energy, and then the homeowner being penalized for it, leaves a bad taste in a lot of people's mouths. And then I think code writers need to get into the field and witness the impact of what has been prescribed, or they need to bring the actual people who are designing and building projects into the discussion. Because, as I said, some of these things don't make sense. Limiting how much battery storage we can install, which means limiting what we can do for a homeowner, while at the same time allowing hundreds of kilowatt hours to be parked in that same garage.
Right.
Doesn't make sense. Okay, builder peace of mind. I want to cover this because this is a question that keeps coming up, and it actually came up as recently as yesterday. So attaching a PV system to a roof. Essentially, if you have a look here, these pieces right here, that's an aluminum flashing. And so the penetration that secures the system to the roof is essentially a lag bolt into the roof truss, into the top cord. Then that penetration is sort of up here. This flashing goes over top of that. We use a thermoplastic sealant, and by we, I mean, hopefully any PV installer does. And then the flashing goes down, it tucks in under the course of shingles above it. And essentially what we're installing here is we're installing an aluminum shingle over the penetration point, which is up here. And then the attachment happens down slope. And this is what supports the rail, which supports the PV modules. So we have a sealed, flashed, covered penetration point that, quite frankly, I've never seen leak after an installation. So that, hopefully that sort of puts a little bit of concern to rest in that regard. The system is weatherproof, waterproof, and leaks on a well properly installed system don't happen. Equipment warranties far exceed anything Terrion requires. PV modules are warranted for up to 25 years. The power electronics are warranted anywhere from 12 to 25 years. And then labor warranties from the installer should at least match what the Terrion requirements are, which is a couple of years. So also the homeowner benefit and the payback for the homeowner are real, and we do that financial modeling for every project that we do for every client we have.
Yeah.
That you want to have a look at and that you want to see. But essentially the business case is there's a cost for the system, and then there's an annual savings from the output of the system, which comes from not having to purchase grid power because you're generating your own. And that cost savings against what the total capital expense for the project typically results in about a 9-year to 10-year payback for the homeowner at this point.
Isn't that something? Yeah, Will, we were talking earlier about this slide, and over the last, I'm going to say 10 to 15 years, this slide with these bullet point concerns have always been the speaking points, right? It's the first place that as a builder, as a consultant on the building residential side, we would go. But our experience has been is in the last 5 to 10 years, these things they're sort of proving themselves out. This year alone, our team will have worked on 400, just this year, for over 450 net zero ready residences. And we're not seeing issues with this. Right. There's professionals like yourselves that are doing excellent work. You're integrating with the trades. The challenges, though, are everything else you've talked about today.
Yes. Yes.
So,
the administrative requirements, I think, is sort of how I term them. And requirements that need to be in place, but are becoming more and more costly. And are not necessarily efficient, and then some of the code rules don't make sense. So these are challenges that I think collectively we need to have conversations about, and then we need to start talking to the right people about how we influence things to go a little bit more in our favor to facilitate the adoption here. Because the push is we want renewables. The push is we want to transition to non-carbon based fuel sources. The governments at all levels want to see net zero, and they want to see this transition happening. The public wants to see it. There's an appetite for it, but then when it comes to the point where we actually want to do it, it gets really hard, and it's getting harder. Like, it's actually getting harder every day. I mean, this summer there was a period of time where it's like there wasn't a day that I sort of went in that I sort of started working and didn't have another challenge to overcome because of a new restriction, a new code, a new problem.
Yeah. You made a really interesting point about going into the field. And I'm going to say, I think we can all take something from that. You said the individuals, and let's put all of us in that context, that are involved in committees, in code writing, in standards and standard development and these things. We have to remember that going into the field is not only a good idea, it is critical. Many of us are familiar with, the Toyota production system, right? the TPD, and Toyota was known for years of being, solving problems, moving ahead and getting good systems and good delivery out of it. And they use this term called Gemba. And what it means is at every level, you need to, before a decision is made, you need to go into the field and see. So I have an engineer, a cousin of mine that's an engineer for Caterpillar, and before they actually will mandate something or do something, they actually have to go and stand at the assembly line and watch it and talk to the people doing it before they can actually make a change.
That would address so many problems. That would be brilliant. Andy, and I think that right there would solve all of our issues. We would figure out ways to do things collaboratively that make sense and that are executable and repeatable in the field, so that we actually can achieve the aim of that which we say we desire, which is we want to increase adoption here. We want to transition. And so I think that's a fantastic sort of approach to it.
So Will, you have exactly 20 minutes and we have 12 questions. So
okay.
How are you doing?
I'm done. Actually, I've got 3 slides left.
Okay.
So, moving from single, sort of projects, single detached homes to multi-unit residential, it's just scale. And so, we do want to involve a couple of extra people when we start talking about communities like this: designers, architects, engineers, purchasers, financiers, construction managers. We want to get at the table and in the conversation. But the process really is the process. It just happens at a bigger level. And then, electrical design becomes very critical once we get into higher scale stuff, because the voltage and the currents we're working for, the amount of PV, how we combine that, where we connect it, all becomes very important. So electrical design becomes a very critical piece. And then energy monitoring. We want to verify systems are performing as designed, and we want to verify that benefit is actually happening and is real. And it's just great information to sort of stay on top of things. So I'm gonna go to questions so that we can just.
All right. Will, that was awesome. All right, we're going to do a rapid round here. So folks, we're going to start with John. So Will, we got 12 to get through. So here we go. John says, he said, I think I might have missed it. He said, can you tell me what the average cost is for like a structural engineer review for stamped letters? I think this was sort of going back to some of the original.
Yeah. So typically that's about $700 to $1,000 is what the average structural engineer charges.
Okay. Stephen asks a question. I don't know if you're comfortable answering this. This is comparing thermal energy storage system for hot water. So he says, does it make the admin process easier to use, say, thermal energy for hot water from solar PV, or heated soil directly heated from solar PV, which is not grid connected? In other words, something that would just be generated and used at the house, as opposed to trying to connect with the grid.
Yeah, it would be, as long as it's completely isolated from the grid. Even if it's connected anywhere and tied in anywhere with the electricity service for the home, that is considered utility interactive and grid connected. So we actually have a thermal battery in the basement in my office that we charge with PV during the daytime, that preheats hot water and does exactly what you're saying. Required all of the same permits, because it's actually fed off of, the solar feeds into a panel, and then we feed that panel. Off of that panel we feed the thermal battery, and so it is essentially utility interactive in that regard.
Yeah. And I think it's a good point. We've had some other statements on here, not less questions and more statements, right? But is it fair to say, Will, that, yeah, there is battery storage, but maybe it's better to say that we are going to need some storage. It may not be batteries all the time. It might be thermal. It might be other things like that.
Yes.
Yeah. Okay. Sean, Mr. Marsh. So what a guy. What a great guy. Sean, man, you know more than I do about this stuff. And from practical experience too. He says, can we install larger systems but limit possible export to the max 10K to the utility to save on all the extra fees? He says, I'm thinking about when we start getting our electric trucks, at Lightning, in 2028, most homeowners will want to store their own hydro and charge their electric vehicles for a fee.
So unfortunately, the answer to that is, well, 2 things. 1, we can do that. 2, it it doesn't impact costs or save us. So we did a project this year for a client homeowner in an area where the grid was constrained. 10 kilowatts of solar, 3 power walls, so 25 kilowatts total generation. Utility said we cannot export to the grid because it's constrained. We still had to go through the connection impact assessment, still had to complete engineering, still had to pay a $5,000. Sorry, this was a $3,500 application fee, and still had $6,000 in connection costs, even though we are exporting zero electricity to the grid. So it's called load displacement. And essentially we generate and store power in the home and we don't export anything to the grid, but that process still needed to be followed because hydro says you are interacting with the grid, you're connecting a parallel generation source along our distribution system, and so you need to follow this process. So even though we're not exporting, we still had the costs.
Okay, good. Sean, I'm going to skip your second question and I'll come back to it. I want to get first questions from some folks. Dave McCauley says to maximize PV area. Good to have you, David, by the way. To maximize PV area, especially on existing roofs, are triangular panels available? We frequently run into restrictions for urban design criteria for gables and cottage roofs. Interesting.
Yeah, it's a good question. And no, they are not. So they're a very custom item. I have seen some projects where, the triangular solar modules were created specifically to handle sort of, that type of roof geometry, but they are not a standard item. They are not commercially readily available, and they are very expensive to do on a custom sort of one-off basis. I'm not sure why, but there's just no market for it. I think there would be, but it just doesn't exist. Yeah.
Well, have you heard any more? I know you and I talked to some folks at MyTech, I think at one point in time, other products that work as panels. Like, have you had any more experience with some of that, or?
Yeah, Mitrex. So there's other technologies out there. Mitrex is like a cladding, so it's meant for sort of high-rise, multi-unit residential type stuff. It works. Again, it's custom. It's expensive, but it depends on what your goals are and what the budget for the project is. So typically speaking, anything that's custom is going to carry a little bit of a higher price, but there are options out there.
Nice. Okay, interesting question. Frank says, at community scale, is virtual net metering a possibility? In other words, if I don't use the energy, my neighbor can.
So the answer to that is yes, cautiously. So there was clarification by this is in Ontario. Every province has their own sort of net metering policy, and in Ontario, it's a regulation that's governed by Ontario regulation. So there is actually provision in there, and there was clarification this summer that it's not necessarily virtual net metering, it's third party. So you can essentially own and operate a PV generator or renewable energy generator, and then you can create credits and sell that energy back to a homeowner, or you can transfer credits from one account to another account. I'm not quite sure the mechanism of it yet because it's a little bit gray there still, but it is possible.
Mm-hmm. Good. Thanks, Will. Dan Vivian just makes more of a statement, I think, and Will, glad for your reaction to this, just mentions, space heating loads are higher than base loads. Obviously, we're here in Canada. The only nuance of that, Dan, is when we start to get into domestic hot water loads, Will and I, electrification, we've actually seen the domestic hot water load exceed the space heating load. But that said, you just say for emergency power, alternative fuels, wood, propane, natural gas make more sense than battery storage. Will?
Yeah, absolutely. I mean, backing up an air source heat pump is not an easy thing to do with battery. It takes a lot of battery and a lot of power. So I agree 100%. Yeah.
Good deal. Jeffrey just has a question, says shingle life is an issue, ... Have you had to dismount a system to allow for roofing replacement?
We have done so. Typically speaking, if we're installing solar, we on a retrofit, we assess the roof and the state of the shingles, and we advise the homeowner to replace the roof if necessary before installing. But we have removed systems that others have installed on roofs that had shingles that need to be replaced, and so it's remove shingle replacement, reinstall. On a new home, should not be an issue for a very, very long time, because the solar array is actually going to prolong the life of the roof.
Yeah, that's a good question. We get, well, what does it do to the shingles? And I think we have to remind that the biggest degradation to any roofing material is UV exposure. And with the panels, you're eliminating its biggest concern. So David mentioned, is rodent resistant metal cabling available? And do you have a sense of the cost?
Well, I mean, cabling, if you're talking about the electrical conductors that move electrons, then I would say Tech 90 does that. But so what we do instead, because it would be very expensive to wire up an entire system with like a BX or a Tech type cable, is we wrap the entire array in a rodent guard, a critter guard. And so that's like a galvanized steel mesh that's coated in a UV resistance PVC coating. And basically that goes around the perimeter of the array to prevent anything from getting underneath, nesting, chewing on cables. We've seen bird problems, pigeons in particular, in certain areas getting under and causing havoc. We've seen squirrels chew systems apart, causing tens of thousands of dollars in damage. So that rodent guard is actually quite important.
Yeah, that's good. I'm going to jump back to Sean's second question because we're on second runs here. I just mentioned, seems to me the power wall restrictions costs, we're quickly approaching a scenario where it would be cheaper, easier just to have that low cost EV with a large battery to keep in the garage as battery storage.
Yes, I would agree completely. That is sort of where all of our efforts go in terms of, sort of design and conversation. And quite frankly, I mean, if you're a client, would you rather spend $20,000 in administrative costs with a utility, or would you rather spend $20,000 on equipment that you're going to own and have use of?
Okay.
So we just have to be careful, because anytime we're connecting anywhere into the electrical service of the home, we're then interacting with the grid, and then there's these other things become requirements. If we do so in a manner in which we keep things sort of separated and isolated, then it gets a lot easier. And I think this is going to be definitely one of the solutions for that.
Nice. A real good question just from David, just asking about type of roofing that's best for PV panel installation. And if it is raised seam roofing, what depth of raised seam roofing is best for PV installation?
Yeah, standing seam metal roof is definitely the best. We have a non-penetrating mounting solution for standing seam metal roof. And,
wow.
and that seam, so basically the attachment method is a clamp that goes over the standing seam and clamps onto it. And then we run the rails and mount PV modules without having to actually drill into the roof anywhere. And so what depth of standing seam? I think typically what we see is like anywhere from 3 to 4 inches of standing seam. I mean, really our clamp only needs about 3/4 of an inch to actually seat and then clamp on. And I think most standing roof seams are somewhere 3, 4, 5 inches probably.
Okay.
So, yeah.
Good. And Will, it's interesting, right? The metal roof, standing seam metal, a 50-year roof with panels that have a 20-year warranty, but you said before you've had panels 20, 25 plus years still running at lots of good capacity left on them.
That's correct. Yeah. Although the warranties sort of go out to 25 years, and manufacturers are sort of guaranteeing that at 25 years, the panel is still going to output a minimum of 80% of what it's rated to use at 25 years. So, I mean, it's not going to shut off the next day once the warranty expires. And in fact, there's systems that were installed in the 60s that are still generating today. So, yeah, they're going to operate for a long time.
Very good. Next question here. Frank asks sort of a nice question. Any suggestions for students? We need good students to get into these industries. Any suggestions for students hoping to get into this space? Where are the biggest pain points or opportunities?
Well, I can tell you there's a shortage of installers right now. I know that there's a number of colleges that run renewable energy programs now, which is probably a good start. I would say the best place to start would be installing, because you get to know that end of it very well, and from that end you can then sort of understand things a lot better. And then I think it would just be a matter of finding a company that is actually hiring. But starting with, because we get a lot of applications for people coming out of the college programs, and they're pretty knowledgeable. Need a lot of work in terms of practical hands-on training, because they don't get that at college, but having the foundation and the fundamentals down actually helps quite a lot.
Very good. Oh, that was a nice question by Frank. A quick question about the integrated solar panels. So BIPV or IST type stuff. Any differences in code requirements or planning for those versus panels?
Yes, we've had to put in alternative solution permit requests when using things like solar shingles, because if they're not in code as an approved roofing material, then we need to put in an alternative solution request so that we can get approval from the building department to actually use that type of thing. And we have done so. It just takes a little bit longer and is a little more work.
Okay. And I think we've had one or two experiences, where there was an integrated solar shingle used, and the insurance companies, even though they don't struggle with panel type PV, they seem to struggle with some of these newer integrated shingle products a little bit to insure. Is that?
Yeah.
Okay. And again, it's those types of things are new, but we'll get a little more. Susan says, can panels be moved from one home to another if you move? If there is a microfit program? Oh, there you go.
Well, you cannot take the microfit contract with you. You can certainly move the PV system. You can uninstall the modules, take them to your new home, have them installed there, but the contract stays with the property, and the ownership of the contract transfers to the buyer who is taking possession.
Okay. And just so folks understand, the microfeed and tariff, that was a program that, had all those nice contracts. It's timed out now. So now we have people that are under those contracts, but they're not available anymore. Really, Will, what you're talking about these days are not necessarily microfit projects. These are just simply panels on, systems in, and it's just a net metering type situation, right?
Yeah, correct. The microfit program ended in 2017.
Okay, good. Dan Vivian, again, just making a point, ground source heat pumps, lower the most significant loads, space heating, active form energy storage. I think that, a lot of the solution lied ground source heat pumps, absolutely taking use of that earth advantage. The big struggle we have, Dan, again, love geothermal systems. I know Will's worked on a lot of them. We have too. The only struggle we have with a lot of the systems is they're often quite large. We still struggle at the design stage to get designers to do proper calculations, to use really good efficient motors, and to properly size loop systems, because they're still all using large numbers, and it just adds to some of those costs. But absolutely, ground as a geo exchange, and I like the fact you use geo exchange. That's let me just say, David made a point that there are some triangular panels on Speedville Avenue East, just west of Woolwich.
Yeah, that's that flower at Terraview's head office in the parking lot there. That was a very custom one-off thing. It's more architectural than anything.
Oh, that's right. Those Andrew and Dave had that looks like a daisy. That's right. Oh, thanks, David. Question: has anyone developed awnings that provide shade devices with PV panels?
Yes, yeah. So we do have some awning options. It's pretty simple, straightforward system. Now, the issue there is, though, that there are still gaps between the actual modules themselves side by side. So, if we're not perfectly weatherproof, you're going to get wet underneath because there's gaps, but for shading, for sure. Yeah.
Good. And last question, Will, and we're going to wrap it up. You've been great. Susan just said, all right, when my microfit program ends at 20 years, what are my options?
Yeah, have it rewired and start net metering.
Okay. Interesting. There you go. Rewired, moved from a microfit, moved to just a net meter. Excellent.
Yes.
Jeffrey, one last question says, are you seeing a greater number of heat pump water heaters and drain water heat recovery to keep demand down? Maybe I'll just take a shot at
you, Andy.
Yeah, I'll take that one, Jeffrey. The answer is yes, we are. In fact, drain water, we're seeing a nice combination technology there. Air source hot water tanks, which have slower recovery rates than what we're used to with gas, tied to drain water heat recovery units, can raise the recovery rate quite substantially for showering, and they work together synergistically. I think that's a nice technology. And to answer your question, yes, lots of air source hot water tanks. We're seeing lots of package systems these days where the condenser's on the inside. In fact, one of these days we're probably gonna have to do 2023, we're gonna do one on air source hot water. But also keep your eye on split systems coming up as well. All right, folks. I think that does it for today. Let me just share my screen. Will, thank you so much. That was awesome. That was great.
Thanks, Andy. I appreciate it.
And even though I can sense the frustration, you folks are, I mean, I think at this point in time, I think, what are you, you're about number 5 or 6 in Canada as far as the output and capacity that you're doing for installed PV in communities. Is that right?
For Powerwall, yes.
Yeah. Okay. Good. So lots of work going on. You're working with a lot of developers. You have a good sense for this, but it is interesting. It's good for the rest of us to see the challenges coming up. And I'm looking again at the number of names that were on here today, and I think some people can help with this. So folks, this is our last one before we go into the holidays. So keep your eye on our Builder's Digest. I think a new release just came out last week. It's got some stuff on PV. It's got some stuff on net zero communities. It's got some cool building science tools. We are going to be doing this series in 2023. Stay tuned for that update in the new year. And I do want to thank Enbridge again just for their support. And they're going to continue to support us even in the new year. So Will, thank you so much. Have a wonderful New Year's and holiday with your family. Keep doing what you're doing. And to the rest of you, thank you so much for your support this last year and your excellent questions and excellent discussion. And I got to say, it's been it's really cool to watch this take place last year, because the conversation's been thoughtful, it's been kind, it's been challenging, but it's been very professional. Well done by Canadians. So have a good holiday. Thanks, folks.
Cheers.